Hello friends, I am Dr. Lokesh Jasrai, and in this video we are going to start hypothesis testing procedure where the first step is bootstrapping. So in this video we'll cover the understanding on bootstrapping, and then we will understand the concept of inner model collinearity statistics based on VIF. So first we start what is bootstrapping. Bootstrapping is the structural model. Bootstrapping in the structural model is used to test whether the relationships in model are statistically significant when we cannot assume the data follows a normal distribution. Unlike the covariance-based SEM, AMOS or Lazaral, in PLS-SEM there is no assumption about data normality and uses non-parametric methods also. Therefore, p-values, t-statistics and confidence intervals must be estimated using resampling process, and that is exactly is done by bootstrapping. It is used for hypothesis testing when your data is not normally distributed. So friends, before going to hypothesis testing procedure, it is mandatory to execute this process bootstrapping. Now we understand how bootstrapping works. From your original dataset, the software randomly draws a sample of the same size with replacement, estimates the model for that sample, repeat this process thousands of times, say for example 5,000, and uses the variation across these samples to calculate t statistics, calculate p-values, build confidence interval for testing the hypothesis. Now we open the smart PLS and understand how does it execute. So this is our ongoing project. Click on new workshop. Now this is our model in which social support, financial well-being, work-life balance, they all together influence happiness, and happiness leads to influence life satisfaction. So now go to calculate and then bootstrapping. Now in this bootstrapping, the first one is subsample. So you can increase or decrease the number of subsamples, but you can take it 5,000 as a standard. Then amount of results, two options are there: most important faster and complete slower. So it is recommended to select the complete slower. Now with this option the software gives full range of the results. Confidence interval method, percentile bootstrap, test type is two-tailed. Now rest of the figures you are not, rest of the options you are not required to change. Click on start calculation. Okay, now bootstrapping is done because certain statistics appears on the model. So now after bootstrapping, we are required to calculate inner model collinearity statistics that is based on the VIF. So now for that you have to go the left hand side option and then click on this inner model collinearity statistics, click on confidence interval, and you can see a one table in which certain statistics are there. So now we understand what does it mean. So now, in this inner model collinearity statistics, one table is there in which certain statistics such like original sample. So this original sample represents the VIF value for each pair of the constructs as per assigned in our model. So say for example, the first pair is financial well-being and HP. So the VIF value for the relationship between financial well-being and happiness is 1.224. Since the VIF value is below 5, so it is indicate that there is no multicollinearity issue in the inner model for this path. So as per threshold value, the VIF should be less than 5 for all the pairs. Now, the next one is the confidence interval ranges from 1.104 to 1.474 for this pair. Now, and its value is below the critical threshold. This means that financial well-being does not create collinearity problem when predicting happiness, and the structural model is statistically acceptable for this relationship. So in this table, first we have to observe the original sample that represents the sample VIF, and then the confidence interval with the range of 2.5% to 97.5% confidence interval. Now we see what does it mean by the sample mean. So the sample mean is the average VIF value obtained from bootstrap samples. When bootstrapping is done with 5,000 resamples, as we have done already, the smart PLS repeatedly estimates the model, and the sample mean is simply the average of those repeated VIF statistics. And it shows the stability of the original estimates. If original sample and the sample means are very close, the results is stable. And in our case, the sample Mean and the original sample, the VIF values for all these statistics are almost same for all pairs of the constructs. Now, the confidence interval, it lies from 2.5% to 97.5%. These represents the 95% confidence interval from bootstrapping. Now, in this case, 2.5% it indicates the lower bound of confidence interval, and 97.5% it indicates the upper bound of the confidence interval. It means that we are 95% confidence that the true VIF value lies between these two numbers. For example, if CI is 1.104 to 1.474, it means the true VIF is expected to fall within this range. It means 1.224, our sample lies in this range also. So in this way, our VIF is estimated correctly. Now, if we talk about overall model, then the VIF values for SSHP, FWHP, WLBHP are below the threshold. It means less than 5. You can see in the table. These VIF values at the confidence interval 2.5% to 97.5% are also below the threshold. Hence, no inner multicollinearity issue was observed, even though SS, FW, and WLB simultaneously predict happiness in the structural model. So, this is all about inner model multicollinearity statistics. I hope you understood these concepts. So, thank you so much for watching this video, and please subscribe the channel for the next video in this series. Thank you so much.